All right, this is a demonstration I do to address the notion that students have this feeling that rockets push off the ground. Okay, so there's a slide in a PowerPoint presentation, and one has a thing underneath the rocket, and the other one is like there's nothing underneath it, right? And then I set this up, right? And the first thing I do is I just show them that it does propel itself, right? So. The second thing, so you know, there it goes. It'll actually launch itself off of here, right? And then I hook it to a force sensor. I've got a force sensor taped here. I've got it on 10 newtons, right? And then I hit the collect button here. And you can see in the background it's graphing the force. I turn this on. And you can see it's recording the force there. And just like me, this is very sensitive, right? So I tap this thing a few times, right? Just light taps, and you can see it changing the force up there, right? You know? Okay? And then what I do is I tell the kids, I'll turn this off so you can hear me, okay? I tell the kids, I'm gonna put this thing right here. So right now, there's hardly anything to push off of, right? If I was standing there at that wall, I could barely feel the wind, you know? Okay? So what I'm gonna do is I'm gonna put this board right here. And this is about 3 or 4 inches behind the blower, right? So it'll have something to push on, right? While it's running, I'll do that, right? Okay? And the question is, will it change? Not at all. That's one option, right? Will it change? So right now it's generating about 1.8 newtons of thrust. Will it change just a little? Like maybe it'll go above 2, right? Will it change a lot? Will it go up to like 3, right? Or 4, right? Or will it change a whole lot? Maybe it'll be 3 or 4 times the force that it was, right? And then I make the kids think about it, and then they have to vote. You know, you could do fingers like 1 is not at all, 2 is a little, 3 is a lot, right? It's going to go up to like 3 newtons, right? Okay. 4 is it's going to go more than 4 newtons, right? Okay. And then you do it, right? So there it is. Yeah, then they want to know, like, right now, if you get it like a millimeter away, right, it'll actually increase the force, right? But the answer is it doesn't affect the thrust at all, right? Now, if you get it close enough, right, then the air is actually going to bounce off this, hit that again, and then you get like a little bit more force, right? So then what I do is I talk about, okay, let's make an air track that's big enough for me to sit on. An air track glider, right? I can coast back and forth. I can push off that wall, coast all the way to that wall. I can coast back. I've got a saddle on it, right? Okay. And then let's imagine that I throw a beanbag full of lead shots. It's heavy, and I throw it. What's going to happen to me? Well, most of the kids will say, well, you'll recoil, you'll go backwards, okay? And I'll go, okay, so when that thing hits that wall there, do I get more force? Is it going to make me go faster? And they all, you know, pretty much agree that my hitting that wall exerts a force on the wall, but it doesn't do anything to me. There's no spooky, you know, action at a distance or something like that, at least not on this scale, right? Okay. And then, you know, I just talk about, okay, so what's a rocket? And then I talk about how Elf is, you know, gets in the snowball fight, and he's like, right? They rotoscope his arm doing this super fast thing, right? And I don't know if that's the effect, right? It generates this sort of, you know, this uniform force, right? But it doesn't matter. Once it leaves my hand, it'll hit that wall, right? Or if it doesn't hit the wall, that doesn't affect the force that's being exerted on me. Now, if you want to develop the idea of, well, okay, what if it's a lacrosse ball? Well, some of those lacrosse balls are going to come back and hit me. That could do it, right? To be sure, NASA with a flame trench, they're trying to keep the fire away from the giant pile of explosives, right? It is a rocket, so for sure, that doesn't happen, right? In the barrel of a gun, for sure those molecules are hitting that bullet many times, right? They're bouncing back and forth, but that's a totally different situation. Anyway, that's the thing I do.